Hi everyone, so this video is about algebraic substitution. So I know I say this a lot, but this is a really important concept in math. It is one of the most applicable concepts to any kind of branch of science or math that you're going to enter into. It is the ability to plug numbers into an expression or a formula, if that was the case, and be able to evaluate for a single answer. So when we have something like a formula, if you think about a equals base times height divided by 2, which is the formula for the area of a triangle, if you know what the base and the height are, you can replace those values, you can substitute values in for them, and then solve out for the area. So that's the concept behind algebraic substitution. You're substituting in values that are known for variables in your expression and then evaluating. So we're going to go through a few examples today, but again, with something like this, every single time you change the original expression or the original formula that you're dealing with, it's going to be a different scenario. So we're going to go through a few and then you're going to do some practice. So let's have a look. So our first scenario, we are given some known values. A is going to be equal to 2, B is equal to -1, and C is equal to 3. If that is the case, then we're asked to evaluate two different expressions. So the process for showing your work for this, the first line would be just to write down whatever the question was, which is written for us here. The second line, we're going to replace those variables with the values that we were given in the question. We replace them in brackets, and we're going to talk a little bit about why that is in a moment. So first step is just to replace the values that you are given with the variables that exist in the expression. So let's talk about what it means when two numbers are side by side like this, one inside a set of brackets and one not. That is a multiplication. So in between those two values and also the two values on the other part of the expression, between those two values there is an unwritten multiplication sign. So on the next line of work, we're going to start solving using order of operations. So I have two multiplications and a subtraction. So BEDMAS tells me that the multiplication has to go first. So on my next line of work, I can actually solve both of those multiplications and then, or I could solve them one at a time if I wanted to, but because they don't have anything to do with each other, because both of the multiplications have to happen before the subtraction can happen, I can solve them independently of each other. Now, I want you to look at something for a moment. I'm going to do this in two different ways. Way number one, when I do this multiplication, is to look at -2 times -1. So -2 times -1 gives me +2, and then 6 plus 2 gives me a final answer of 8. That's one way I could look at this question. The other way I could look at this question is, let me write this out. So I'm going to solve that first multiplication with the 6. The second way I can look at it is leave the subtraction and just do the 2 times -1, which gives me an answer of -2. Then I have two negatives side by side to one another, so that's going to collapse to be a plus, and then I get a final answer of 8 on that one. So two ways of looking at it. Either you take that subtraction sign in the middle as a negative sign on the 2, as we did in the first example, resulting in a +2, or whether you leave the subtraction sign as we did in the second one, and then collapse those two symbols later. Done properly, you're going to get the same answer no matter what. I would say this first method is perhaps slightly more straightforward. Maybe you may feel differently about that, but provided you do it correctly, either one of those options will actually work. Okay, let's have a look at the second one. So second one, we have c² plus b. So again, first line of work after I've written the question down, I'm going to replace the values of the variables with every other part of that expression remaining exactly the same. And my b is -1. Okay, so order of operations again tells me I've got to deal with that exponent first. So 3 squared is going to give me 9. And then in this same step, I'm going to collapse those two symbols to give me a minus. So I'm going to have 9 minus 1. And then final subtraction there will give me a final answer of 8. Okay, let's look at a couple more examples. So slightly more complicated, maybe not more complicated, just larger. So we've got P is equal to 3, Q is equal to -2, and R is equal to -4. So we've got two expressions here using those variables and those values which we are asked to evaluate. So again, step 1, replace your variables with the given values. So Q is -2, and then all of that is over. And remember, that fraction line represents division. So in the end, we're going to have to look at that as a division, potentially. And then on the bottom, we've got R, which is equal to, I can't see it behind there, -4. Okay, so then first step is going to be to evaluate the top. Those two minuses collapse to give me a plus. So on the top, I've got 3 plus 2. So on the top, I have 5. On the bottom, I have -4. So I look at this primarily as a division. I can't do the division of 5 divided by -4. So I'm going to leave it as a fraction. I'm going to reduce it to lowest terms, which in this case it already is. The only thing I'm going to do to tidy that up a little bit is I'm going to move that negative up to the top, because traditionally that's how we would write fractions. Okay, and let's look at the last example. So in the last example, we have Q squared. So we have -2 in brackets squared. Very important to have this particular value in brackets, because the negative has to be included when we solve that power of 2. And then we have plus, and then P is 3, and R is -4 in brackets side by side, representing that those are actually being multiplied together. And then on the bottom, we have 3. Oh, I want to keep this all in the same color. So 3 plus, and then we have R, which is -4. Okay, so let's have a look at what we can do first here. BEDMAS says I need to start with those exponents, but at the same time, I can also do this multiplication, because both exponent and multiplication need to be done before that addition. And even while I'm at it in the same step, I can collapse that in the denominator spot. So let's see where that gets us. So -2 squared means -2 times -2, so +4. Then we have plus, and then we have 3 times -4, so that gives me -12. And then all of that is over 3 minus 4. Okay, so now on the top, that's going to collapse to give me a negative. So on the top, I have 4 minus 12. So that gets me to -8. On the bottom, I have 3 minus 4, so -1. Remember, first thing I'm going to try to do is a division if I can, and in this case I can. -8 divided by -1 gives me a final answer of 8. Okay, so that's how algebraic substitution works. So a few sort of points to remember here. One is when you insert values originally in on that second line of work, all of those values need to be inserted into brackets. We don't want to use multiplication signs, because now that we're dealing with math that has variables in it, that multiplication sign is just asking for trouble, because it looks too much like an X, which could be part of some of these questions. So no multiplication sign. Keep things in brackets. When you have two values side by side in brackets, that is an implied multiplication. Remembering that the fraction bar is an implied division sign, which we try to do first, and if we can't do the division, then we look to reduce to a fraction, like was the case in this third example. Okay, and that does it. Thanks so much for watching.